Git is like the small talk of software development that you pretty much can't avoid. And here's everything I've ever needed to know about it. So typically the way we use Git is that we'll have this main or master branch. In this case, it's called main. And that represents all the current state of the system, that is completely, everything's working fine, well-oiled, there are no issues, problems. Anyone can branch off from that main master branch and everything will work perfectly fine. Sometimes we use it differently. Sometimes the master branch we reserve for the last release that actually went to production, so the last set of files that the end users are actually using. And in fact, it's a good idea probably just to clarify some of the terminology we use. So a branch represents a certain state of the files within the repository. And so a branch could have stemmed from any other branch. And when you commit a set of changes within a branch and you publish that, that's called a commit. But enough of that. One of the first things you're always going to end up needing to do in Git is to clone a repository, because you're not going to start off from scratch, are you? So on GitHub, I would usually go here to the code drop down, copy the HTTPS link, and I'll tell you later why I usually use HTTPS. You can use SSH and other ways of cloning the repository. And then I will go into my IDE of choice. In Rider, I would then go, you can't see this, but it's file open, get from version control, and I'll paste the link and it'll clone the repository into that new folder, and then I can get going. But I think it's interesting to know what this actually does. So if I bring this up here, I'll put all this stuff down in the description. So what Git actually does when you do clone is it initializes a new repository in that directory that you specify. Then it adds an origin, which is the remote repository, the remote set of files that's stored in some server somewhere. And then it fetches everything. Main or master branch on the origin will then be checked out. So let's say I make some random changes to a file here, and I don't actually want these changes to be part of this branch. Then I can go into the change list, which is all the files that I've edited, and I can right click and hit Shelve Changes, testing. Now Git has reserved that set of changes, and what the state of the files are. And then if I create a new branch, so in fact, let's show some other functionality. Let's say I want to make a new branch from this commit down in the history of commits. This is just some random repository I've cloned from GitHub. Then I can right click, new branch, and I can just make a branch from any commit in the previous history. And then I've checked out my new branch and it's currently loaded. Now I can go to that testing change list that I've just shelved, and I can unshelve it. Okay, so now I've already realized the problem. I can't in fact unshelve this because there's a missing base, which means the file didn't actually exist on this new branch that I've branched off from. So another thing that I often do is I right click on another branch that's not local, and you can hit show diff. This is in Rider. I'm sure there's something similar in Visual Studio, and I can see all the files that differ from the current branch that I'm working on. And so there's a readme.md in GitHub/workflows. Maybe that's what I was looking for. There's another readme here. So I just don't know which readme this is meant to be. See, now we just straight up troubleshooting. Okay, so it looks like this readme file was in the root of the repository, and at this branch that I just branched out of, there isn't a readme.md file, so I'd have to go and create a new file, readme.md, and then unshelve the changes, and it would override it with the changes in this one. But I'm not going to do that for now. Another thing that I often also do from looking at previous commits in the history is cherry picking. And what cherry picking will do is it'll look at the changes that were made in that commit and apply those changes on that commit to your current branch that you're working on. So if I cherry pick here, it's going to give me a whole load of conflicts because I forget even what branch I branched out of. Another thing that's very useful is reverting a commit, which essentially does another commit, which reverts the changes of that commit. Now, something I've also done once or twice is not git revert, but git reset. Where's that? Reset current branch to here. Never done any other option other than hard. I know that a hard reset just takes the current head of the Git repository, which is basically like the last place that the most recent commit, and just takes it back to whatever branch you're looking at and says, no, this is the latest one. Everything that was after that is completely discarded and lost. So if you do that, make sure you make a backup of your repository, because you could mess things up big time. But I'm going to get to recovering and reverting a bit more later. Otherwise, the most frequent thing I do in Git is simply fetching all remotes, which I think in Rider runs this command here. And in fact, I've set shortcuts for fetching and updating in Rider. I set Shift Command 9 to fetch remotes and Shift Command 0 to update the current branch. One thing that's every developer's cup of tea is resolving merge conflicts. Usually this will result from someone else's branch having a whole load of changes that completely conflict with what you've got in your system, and now you want to update to what they've done, and now you got to go through each file and select certain bits of what you want. But in this case, I don't have that, so I'm just going to say, let's imagine I wanted to revert this commit, which is far back in the past, and I'm going to make a new commit that reverts the changes of this one. And so I'm going to have a whole load of conflicts. And I have all the IDEs, Visual Studio, and obviously JetBrains Rider have their own Diff Tools integrated. But I use Beyond Compare, which is going to start up. And okay, so as this loads, there are only 4 things you need to remember with any Diff tool. They pretty much all look exactly the same. And number 1 is that left is for local. That's what I remember every single time. The left pane is where your local repository. The left pane is what is currently on your local repository. The right is what you'll be merging, the changes that will be merged onto your what's in the left pane. You're taking the changes from what is on the right and like putting it onto the left. In the middle pane is the common base, so the last version of this file that both of these. Now, one thing that is every developer's absolute cup of tea is dealing with merge conflicts, which is something that'll happen quite a lot, especially when you're merging in changes from other people's branches that completely conflict with yours, and now you need to go through file by file and say what changes you want to keep and what you don't. In this case, I don't have an example like that, but if I just go to a random commit and go git revert, then cool, so there's going to be a nice conflict. Cool, so now release.yaml has some changes that conflict, and basically what that means is we have a common base, and there's this branch that forked off here and another branch that forked off there, and since that point in time, both of those branches have had changes to them, and in this case I'm referring to my local branch and this branch that I'm reverting from. Which changes do we choose? Which are the correct ones? All the IDEs pretty much have their own diff tools, but I typically use Beyond Compare. And the main thing to remember here is that left, L is for local. So your local files are on the left pane, and then the right is the commit that you're merging from onto the one on the left. The middle pane file, that's the common base between both files where they're both branched off from. And then at the bottom is your what results. And so the main thing is here, I usually use, I think it's Alt Command right arrow and Alt Command left arrow. And that will choose, so if I put my cursor down in the resulting thing, and you see this is all red, which means I'm choosing the text from the file on the right side on the remote that I'm merging in. And if I do Alt Command right, it'll choose all the stuff from the right. Alt Command left will choose all the stuff, the local file. And then there are the shortcuts for moving to the next set of changes very quickly. And then you can just choose what you want. And the main thing here is that you need to have an understanding of what the code is doing, because otherwise, how are you going to pick what change to conclude? And then you just save the file, which I'm not going to. Okay, the next absolute winner is Git Credential Manager. And if I just open it over here, here's the GitHub repo, which you can just clone from, and then run the jar file. This has actually helped a lot with managing using different credentials and just cloning repositories in a much easier way. So earlier I mentioned I use HTTPS. So if I clone this HTTPS URL to a new repository, I don't need to store access tokens or anything. Git Credential Manager can do all that for me. And this is how you can install it here with Homebrew. If you don't have Brew installed, the package manager on macOS, then you're losing out simply. But all these commands and stuff will be down below. And then another thing that can be useful is this use HTTP path, and that basically just means that if you have different credentials for the same, like on GitHub.com, say you have some repos that you want to use this login and some other login, this will basically prompt you each time, and you can log in with the Credential Manager, which just makes it easy. Other ways to log in is you can store this in your .gitconfig, but that's just, it's right there for not necessarily the most secure, but you can store stuff in your local Git config and then in your global one as well. Never actually had to deal with that, don't know much about it. But one thing I do if I scroll down here is I've often just configured my username and email address to be different for a certain repository. And I mean, this is kind of cool because you can change your global to be like your actual name, and then a certain repositories you can be like Darth Vader. Okay, the next thing is ignoring files, and this is kind of useful. I don't actually do it that much, but you can ignore certain files that match certain regex strings, files that have certain extensions, and you can also, what is good to know is that if you've committed a file to a branch and it's already tracked, it's in the history, but now you want to remove it but keep it on your local system, you can also do that with the git rm -- cached. I think if you do -d, it deletes it from the file system and from your commit, but then it just adds that as a part of the changes for that commit. Then the BFG, I don't know if we can go over what that stands for in this video. This doesn't add any new functionality to what you can already do with Git, but it does it a lot faster and it's a lot nicer to do. So let's say, for instance, you happen to realize like a week later that you'd leaked some passwords to your remote Git repository, and now you want to hide all those because you can't change the password just yet. Then the BFG is here to save you. So just clone the GitHub repo, then have your passwords or whatever strings you want to replace in a text file. Then you can essentially rewrite your entire commit history. So I think it'll basically be generating new commit hashes, but it'll keep the commit messages and everything exactly the same. Rewrite your Git commit history and remove and replace all instances of the password text that you have in your text file with a new string, and that can save you. But I would also clone make sure you have a backup if you can. Make sure you back up your repository because you can wreck things. And then of course you can revert commits. You can revert just the head, which is just like the last commit, a certain number of commits. Again, you can reset the UI functionality in my IDE. Just does this sort of thing for me, but it's useful to know that you can either revert a set of commits with a new commit, or you can just reset the head to previously in the history. And lose everything. So that's why you got to make sure you know what these things are doing. And then one thing I've had to do exactly once is do some pair programming out in the mountains, which was a lot of fun. But we had to clone a repository onto a hard drive so we could both use it. So these are just some commands that I copied from Stack Overflow, which was useful at the time. So that's pretty much everything I've ever needed to do in Git. If you came across a use case that you found you didn't know previously, be sure to smash that like button after you've subscribed. The main thing is that it's hundreds of times more important to be aware of functionality than to know exactly how to do the specifics of everything. As long as you know that it's possible to revert a set of commits that you made where you leaked an API key, then you will find out how to do it when the time comes. Oh, subscribe. Did I tell you that? Yeah, I did. But just make sure you